Hello and welcome. I'm Bill Wake. We're working on BASI. It's a basic interpreter, and we've got a lot of our expressions done, and we decided to switch over to control structures and look at GOTO a little bit. And I think what will happen with that is we're going to figure out this thing of making the interpreter run one step at a time. So we can do tracing and watch for, figure out how to exit infinite loops and things like that. So GOTO is going to provide us with a good opportunity for an infinite loop, I imagine. Okay, let's get over to the IDE. Okay, so well, maybe I'll slide down here again. This picture keeps coming up. So an interpreter is a lot like a compiler. You feed in some text, it goes through some lexical analysis, also called scanning or lexing, and that produces a stream of tokens. So it looks and finds keywords and variable names and operators and so on. So less than or equal becomes one token. Then we do syntax analysis or parsing, and that produces a tree of nodes. So one of our nodes is the print node, and it has an expression, and expression is another node, and we're going to build up this giant tree of these. Well, not giant, but we'll build up this tree of nodes. Then the interpreter takes the tree and figures out what to do. So for a print statement, it says, oh, I better evaluate the expression first. And so it kind of recursively evaluates the expression. And then it comes back and says, okay, now I'm going to print it. I'll take the expression I evaluated and format it as a string and put it out there. Okay. And so the input and output of your program, along with a tree of nodes, that's how your program runs. Now, compiler, instead of interpreting, you'd have a code generator. Well, you'd probably have more analysis, but a code generator and maybe some more optimizations and so on, but it would spit out a program that takes input and output. Okay, so the front half is very similar. And actually, I think one of my goals with this project is at some point I'd like to turn it into a compiler. I have a refactoring I ran across that basically can take an interpreter and turn it into a compiler and give you kind of V1 of your compiler. So we'll get to some point and then do that, and I imagine I'll probably finish the interpreter and go from there. All right, so for our GOTO statement, let's find Lexer. All right, we've got a mechanism to identify keywords, and GOTO is one of them. So we have a GOTO token that gets formed, and then that feeds into the parser. GOTO says, okay, skip over the word GOTO, find the integer, and now build the tree this is the tree rather than the token, but it's a GOTO tree that takes one argument, the integer line number. Hey, threading issues resolved. Oh man, that's a good day. Cool. Oh, that always feels so good. I get little goosebumps for you just thinking about it. It's like threading issues, man. They can take you down. Okay, anyway, we've got our tree with the GOTO in it, and now we need to interpret it. And I think we left off there. I don't even know if we wrote a test for it yet, but I had my evening insight, I guess you'd say. What I've been calling interpret, that executes one line, like this one executes line 10 print. Okay, I think that really should be step, like run one line and see what happens. Okay, so let's see if we have a GOTO. And I don't know, yesterday I thought I'd start more with the program structure, but I think we can get this GOTO working and then clean up around it will be a better way to go. Okay, yeah, there's print. Okay, so we don't have a GOTO. Let's make a test with a GOTO. Test GOTO. Well, let's call it 10 GOTO 10. Okay, so we'll start with an infinite loop, and it'll be a lot like these other ones where we build up a tree. So I'll just steal the structure. Okay, so parse program line 10, and this is GOTO, and the argument is 10. That's the line. Everything balances. Okay, so we call the interpreter with empty program, and that's the part we're going to clean up, and we interpret parse, this is the initial output. And what we expect, well, we have the line number. This is really the state, and I think we need to maybe extract that too. But let's say interpreter. Line number should be 10. Okay, and then, so I guess when you say interpret, you're assuming you're going to interpret the line you're given. Yeah. We don't need the output. I guess you're going to insert and assume you're interpreting the line you're given. Let's make sure this is zeroed at the front. Where do we set that? Programmed out first line number. We made that be a 0. It's kind of a hard way to get at it. But yeah, so we should be able to say after initialization. Sometimes we do these assertions to make sure the initial state is what we think before we do something. So normally I'm an arrange, act, assert kind of guy. So arrange some stuff, do the thing you want to test, and then test it and make sure it looks okay. Once in a while, I do arranging and then check the status, make sure it really is the way I think it should be, and then do my act and assert. Okay. It's sort of a sign. You could split it up into 2 tests, but I think we may change the way this works. So I want to be explicit and make sure it really is 0 here and 10 here. But this test should fail. Our GOTO just says return GOTO not supported, and we don't do anything with the output. So I expect the line number to be wrong. Okay. I guess it's the first run. So, okay, 1 failure, and hopefully it's 0 is not equal 10. Yep. Okay. Good. All right. Now the question is, well, no, the question is not that. The thing to do is we need to capture the new line number. Okay. And this thing is returning output. I think that's going to be a mistake, but in the long run. All right. There should be no output. Okay, so we'll just this is the initial output. We'll just return it. But we have to have a side effect that's line number equals new line number. Okay, and so I expect this test to pass. All right, so I guess the thing is, who's going to get the next line number for this thing? That's okay, let's make a different one. I'm not sure we want to do this one right now, but let's write the test. Okay, so let's do 10 go to 20. And our program has no line 20. I think we can trust this now. And something should go wrong. Okay, but we don't have an error mechanism here. And I mean, do we just print something in the output? I don't know. I think that's a decision we're going to have to make. We're going to have to figure something out. So whoever calls interpret, I think from the interpret perspective, it's going to set the line number to 20, and then whoever goes to get the next statement is going to have to be going like, hey, there is no line 20. Okay, so I think we've done our job. So I'm gonna say this. Let's see. Let's express it more. Go to missing line. How about interpreter? Well, let's call it step because I'm going to change it in just a minute. Step will go to missing. Will even go to missing line. Okay, and so I think that is true. If you say 10 go to 20, our interpreter method, it's just going to set it. It's not worrying about where that next line's coming from. That's going to be some other job, somebody else's job. It's just going to say the next line is 20, and then that other person is going to have to say, hey, I'm going to fetch line 20 now and interpret that. Wait a minute, there is no line 20. Okay, so I think this is actually right for now. All right. So that's all I expect out of that interpret for GOTO. So interpret GOTO. Single step. Okay. Now. All right. So what I've realized is whatever run is, that's going to, if we keep that, it's going to be the thing that repeats and decides and all that stuff. This should really be called step. And I think I feel so much better with that. Okay. So give me a parse. I don't know if this output's still a little funny. It's all focused on output, but I think really it's like state. And whether that should be a string, that seems suspicious to me. I don't know. I think it maybe should be an object, and that's the object that our console monitors. But, okay, so let's run all tests. I guess I didn't do that again. Man, I'm getting sloppy. Okay. Rename interpret to step. All right, now let's see what we can do. So another thing that bugs me, this parser Lexer line stuff, I feel like the parser should just be there. Maybe it needs a Lexer, but Lexer wants a line. I don't know. I almost feel like we should be creating a parser that takes a Lexer and then feeds the line in. All right, let's go look at Lexer. So we're into a refactoring mode. What's the complaint? Oh, what, is that easy? I don't think that'll harm anything. Okay, build. Well, let's do a cleanup. Clean test results. Clean build folder. Let's run test results. Okay, I guess I will revert that one. So much for the easy upgrade. Now I'll have to figure out what's going on there. And make sure this is back to normal. Apparently I haven't signed something or whatever. Okay. All right. So let's see. I was going to find Lexer. All right, so our Lexer, it is a sequence. I'm not sure we care too much, but you feed in, well, here, where's the initializer? You feed in a string. It does some formatting on it. Basically, it squeezes out the spaces and makes sure it terminates with a line feed. And then you, well, index that, lets you get the next one. Everything else is all kind of helpers. Next is the one we care about. So it's oriented towards a whole program at a time, and that's not the way we want to work. So we're making a big change at this point in how we interpret the lexing process, I guess. I don't even think, well, yeah, it's okay, I guess, but because we really don't want to see the end of file character there, right? That's not relevant to us anymore, I don't think. I think, let's see, this is probably only needed if there's not a new line on it. Should init take the string? I mean, init doesn't, sorry, the Lexer doesn't really have state to speak of. It's got one variable. This is set at initialization, and this is managed as we go through. But everything else is just helpers, you know, data structures with maps and whatever. Okay, so this, and where's the end of line? That's fine. End of file shouldn't happen. If we're only feeding in a line at a time, this will never be relevant. We should only go there. Okay. In a normal programming language, if it's a compiler, right, we would have to worry about end of line and end of file. You know, I think for us, we won't, because when we parse, let's go find our line, parser. It's up near the top. Line. Okay. So line finds the line number, and it requires an end of line at the end, and then it's done and it returns the line parse. That's the piece we care about. And yeah. So we don't look for end of file here. We only look for at end up at the program level, which assumes it gets the whole thing, while token not equal at end. Okay, so what do we want to do? Lexer. I mean, what I want to do is build the parser, let the parser sit around, but again, maybe it doesn't matter. I just feel bad creating new parsers all the time, because he's got a new Lexer, so he's got to create a new parser. But a parser doesn't have that much state either. It's got the error messages. That would be useful to hang around. Yeah, that might be useful. I just don't know. Okay, let's go back to interpreter. Okay, so our step, you feed in a parse. So somebody parses the line. And parse, let's check that one out. I think parse calls program. Okay. I think our parse should call line. Okay. And let's see what happens if we do that. parse calls line. Some of our high-level tests should break because we have tests that assume. Okay, sure. Oh, that gets dealt with in here. Okay, let's undo. Program. All right, let's. This is more of a spike, I guess you'd say. I'm just gonna see what happens. I'm just gonna call line. See who breaks. Something should. If it doesn't. Line set append. Maybe it won't. Oh, what? Oops. Parser. Line returns a parse. Oh, yeah. Okay, so we'll return it there. It really can't get here. It'll probably complain. So it'll call line is unused. Unused, yes, that I can believe. Return try line. Why is that unused? Result of call to line. Line should be giving us a parse, and we're returning that parse. I think this might be a mistaken. All right, and lines was never mutated. Okay, yeah, I believe that. Okay, it lost the message when it built. Okay, 5 failures, and where are they? Parser tests. Print statement. Okay, that shouldn't matter. Program equals 25 print. What did we get? Line 25. Print is not equal to program. Right. We're not getting program back anymore. We're only returning lines. All right. If that's all if that's all they are, yeah. Multi-line, that test goes away. And GOTO, again, return program. Okay. Yeah, I think that's what we want to see. So I think these should just become line. Oops. Let's try Control I. Oops. Isn't it Control I? Okay, there it goes. What's my go-to? Go-to, so no program. Take off bracket. Parend. Multi-line. Let's make this test. We'll just mark it not being used, and I'll take this off and this off, just because we're going to get rid of program. Okay. Oh, okay. I'll take it back. All right, but we'll leave it X'd. This one result is line. I guess I did that one. And then this one. Result is line, and then this one. Okay. Now I think the test should pass. It's kind of a backwards way to do it, isn't it? Oops, multi-line. Wait. Why did you run? Oh, 0 failures. Okay, he's just marked still. All right. So now we're saying this doesn't need to be there. Okay. I actually want to pull this down into line and call it line. Where's line? Well, line's actually got some stuff to it. Maybe I'll call this single line. This, I don't know, I've talked before about trying to tell the story from the top to the bottom or vice versa. I think it, let's move this. I'm going to use the another way of doing it, I guess. So I think of, I guess I flash back to math class, right? And sometimes you had a big proof, and so they define some lemmas first, and the lemmas are like helper proofs that you can just use. I think of these as the same way, that I set things up. I tell you some fundamental things you ought to understand, like, oh, we do have a way to get errors, and there is a next token, and there's a require. Move this down again. There's a require that looks for a token. If you understand those things, you're going to understand the rest of the file, which is the parse. And within the parse, then all the rest of it is sort of telling the story top down. Parsing looks for single lines. That looks for a line. That looks for statements and line numbers. Well, line number and then statements. And then statement looks for all these things and so on. You know, that becomes, once you get through the lemmas, it becomes top down. Okay. And I go back and forth as to whether it's a good idea, but I think in this case, you kind of need to understand next token, require, and then you can make sense of parse. Okay. If I didn't, then I would have all that stuff at the bottom. I don't know. It's this could be private, I think. I don't usually bother marking a lot of stuff private, but I think in this case I will. Lines was never mutated. Yeah, we should fix that. Okay, so we don't need lines. We do want the catch. I don't think this can happen. Oh, I guess it could happen, right? I think we have an error parse. Parse. Well, I'm going to return skip. No, I really should return an error. The real thing is you're gonna append some error messages to your thing. So I think your program is. I think it would be okay to return skip. Skip. No parens. And I'm going to put that in here just to emphasize that that's where it's coming back. Okay. Yeah. Let's make sure. Okay, so parse looks only for one line. Okay. Now, right. So I'm wondering if, I think maybe we made a decision like, oh, we'll give the Lexer at when we build the parse. I'm thinking maybe this is not the right time for it. Maybe we should give you that. Maybe we just build this up so it can hold all the error messages, and then parse, we pass that into parse. Okay, so let's, excuse me, let's make that change. That's a moderate change for sure. All right, so I'm going to say that when you want to parse something, you just give me the Lexer. Although, I don't know. It's like, do I really need to substitute Lexers? I don't know that I do. I kind of hate making one. I don't know. Maybe that's not bad. Maybe if parse takes the string and then I build the Lexer here, I'm going to try it. Okay, but I don't want to break the world, so let's do this. Function parse takes a string in input of type string, and it produces the tree. Okay, and let's make this a var for the moment. So I'm setting up this big refactoring where I'm going to move everybody from parse nothing to parse with input string. And I'm providing both methods kind of in parallel so we can change them one at a time and not break the world. And I'll show you what I mean in a minute here. But if you do this, then let's say let Lexer, well, nope, just Lexer equals Lexer sub input of input. And then we need to do the token equals next token thing. This, well, which is the same as next token. Okay, which we call it prime the pump. You know, we're getting that initial token ready so that any routine that's trying to parse things has the first token ready to go and can look at it. Okay, so now this doesn't break anything because nobody calls it. And one of my slow speed projects, like so many, is I want to make some refactoring videos that demonstrate these kind of medium-sized techniques for refactoring, because not everything is like hit extract method and the compiler does it. You know, some of these take some more doing. So if I didn't do this, let's comment this out. Oh no, let's comment this out. Okay, suppose I said here's the way everybody should be, and let's do it. I'm going to get a bunch of compiler errors because all these places that assumed they assumed there was a parse method, now they're all busted. Okay, and you know, I don't want to live with everything busted and lying on the floor while I switch over from one to the other. So I'm providing both, and I'm going to find callers of this one. Well, we know where the big one is, right? Let's try this. Okay, so see, we've done parse equals parser of lex.line.parse. Okay, let's do something, try something different. Let's say parse equals let's do parser of, we're going to ignore it for a minute here, Lexer of nothing dot parse line. Okay, and this comments out. All right. Okay, and apparently I think they're just not caught up. My expectation is everything should pass. Whether that will be the case, we'll see. Okay, so we created the Lexer and ignore it, and we'll get rid of that parameter in a minute once we get this other thing moved. Okay, so yeah, so what you should notice is I made one change here. I've still got a bunch of places that use the old style, but I could stop and check this in at any point. I would have the downside that I've got duplication of two ways of doing something, but I can, you know, if this were 1,000 calls, I could still do them one at a time and fix them, and or do them 50 at a time, or whatever's convenient. But let's start there. And the other thing is, I'm using Xcode, which is not very mature on refactoring. So if I were using app code, or at least if I were doing this in Java or C# or Kotlin or a bunch of other languages that have pretty good IDEs for this, there's a way I can say change the parameter on the parser and eliminate this parameter for free, instead of what I'm going to have to do is go do that manually. But I'd rather take the smaller step. If I had the IDE, I'd use it, but if I don't, I'm going to take the smaller steps. So that's why we're doing this kind of thing. So let's find another instance, another caller. Find symbol. Okay, and mostly, okay, here's interpreter.run. Okay, now this one, interpreter of program. That feels okay. Where's the word parse in there? Okay. Parse, yep. And it's just tests. Okay. So we say parser.parse, and let's do program. And I'm going to change that to line while I'm here. Okay. Parser.parse of line. Let's make this line. Parser.parse of line. And what you should notice is this is very mechanical now. I don't really have to think about what's this code doing and is it going to be affected and all that stuff. I've set it up so it's just going to work with the new approach, and that's a good thing. Now it does suggest a more generic name would have been better in this case, and really these were just single lines. I probably should have called them line in the first place. You're definitely welcome to call me on stuff like that anytime. Yeah, okay. Where are we? Well, this one is a program. Okay, this one we're saying is no longer a necessary test. Parser.single line. Oh, interesting. Okay, I think this one's questionable. This one's questionable. Is that parse? Okay, I think because we've made single line the same as parse, then I should be able to call parse now. And change that to line. And same deal here. Okay, and let's run this again. Good. Okay, well, they all have a parameter. Parse line, okay. Run all these. All right, and commit. So what we did was make parse take an input string as parameter. instead of using the one from the constructor. I should have said refactor. It's well, it's a manual refactoring, I guess. But it's still intended to be refactoring. Okay, so now I don't think anybody's calling this one anymore. So if I comment it out, oops, what am I doing? All right, that should be fine. Okay, so we'll kill that. Okay, and now this thing in the initializer, the Lexer here, nobody ever uses it because it's always overwritten here. So let's take this out. Well, I guess we can take the whole method out. Okay, and places are going to break. There's no initial. Oh, I have to be explicit. Stored property Lexer. Oh, interesting. Why do I have to have those? Okay, we'll just give it an empty one. Okay. There should be complaints all over the place. All right, so parse that takes a Lexer, and Xcode, it runs your, it does them a project at a time for unknown reasons. Okay, and if I run these again, it'll find all the test ones. Oh, cannot infer, huh? Well, that's weird. Result equals parser.parse. I think that's probably okay. I think once it runs again, because it knows the type of result, it should be able to figure out that it's matching a result. And again, I could have defined a second initializer that took nothing, kept both of them at the same time, because I know they're all kind of in one place or at most a couple places. I'm being a little lazy, but in a big program, I would definitely do 2 initializers until I got it all straightened out. Should be getting to the bottom here. Oh, these are going to break. I don't think there's an easy solution. Program never used. Yeah. Okay, so let's run them. I think we may get them all. Right. All those expression ones fail. And this is yeah. So what happened is we jumped into expression in the middle of the thing. What would be the right way to do this? Because the problem is 1 + 2 + 3 is not a valid line in BASIC. And I don't want to. Let's see. What do I want to do? I mean, I could give you expression as. I could let expression take a string and provide a second one that builds up for lexing purposes. And then it would have to do the same kind of thing. It would have to do this stuff. Let's try that. I'm going to call this test input to kind of remind myself that something is not right. So the deal is our parse tree is 2 levels. It's got the parse, which is kind of the lines, and then it's got expressions of their own subtrees because they're just so complicated, and expressions hold expressions and all that stuff. So that means we don't really the expression stuff is so complicated on its own. I just wanted to test it. I could have put everything. My alternative is I could turn all these into, line 10, print 1 + 2 + 3 and check that stuff. And that may be the better way to go, but I'm going to make the cheap change first, where I'm going to copy this stuff, the setup here, and do that in my test expression one. Another alternative is I could make this a helper method extension only for tests. Try expression with no parens, and this is test input. Okay, and so if my test's called expression with program, which is really expression, I don't know why I called that program for sure. Let's see if this test passes, and then then I'll go ahead and make the rest work this way. Okay. Yeah. Parse expression. And the downside is it's knowing the structure of the parser, or that it can trust that all the stuff above it doesn't really matter, and we can just come in here and do this. I guess. I mean, it's a compromise. It always is. But I think I will pull this as an extension and maybe leave it in here for the tests, just to make it a little bit more explicit that it's for testing purposes. Now maybe that, maybe it's telling me expression deserves to be its own class or its own like expression parser or something. Let's see if we're passing first, and then we'll make those big decisions. No. Okay. What's going on? Program. I guess I missed one or more. 2 or 4 and yeah. Oh, these were the helper methods. Yeah. All right, and let's see if I can pull this one out. I don't know. I think that's probably legal, but next token inaccessible. Parse. Oh, I made it file private like 2 minutes ago, 10 minutes ago. Okay. Let's run this again. Right. So the downside of what I did there was, well, the upside is I took this expression that takes a string and knows it's built based on the contents of the parser, and it knows I could just call expression if I set up this stuff correctly. That's sort of a weird thing. The downside is if I change the way the parser works, it might mean I have to open up a test class and change this. The upside of this is I don't have this confusing test-oriented method in my parser. Now I could have made this a subclass or something and used that, but I'm kind of taking the cheaper way of just doing an extension. And I have indicated test input, so hopefully that's clear enough. And if these start breaking because the parser changed, well, you're going to have to change the way the test accesses this. I don't know. The other alternative is if I pull out the expression parsing into its own file and its own class. I mean, they are somewhat different. But in normal use, right, I'd have to make sure they still had access to the token. They got to be the same token stream. So the same Lexer. Yeah, I don't know. Yeah, I'm gonna keep it this way. All right, so we provide a test method to test expressions not in state directly, not in statements. Okay, and I think we're making progress. Oh, I need to update my to-dos. Okay, so this we got GOTO working. That's a good thing. All right, and then make interpreter work one line at a time. That is what we're doing. Delete parse.program if we work one line at a time. Okay, so I think that's probably where we are next. The interpreter working one line at a time, that's that step method. Okay, and step. Okay. Yeah. So the structure of step, where's step? Step. Okay. Yeah, this case is going to go away. How do you deal with a line? Maybe I don't need the line numbers in these things at this point. I don't know. All right. If you have a program with lots of lines, we're going to ignore that. Let one line with a statement. We're going to step on the statement, which is a skip, a print, or a GOTO at this point. And yeah, so program can't happen. That's interesting. Let's see the consequences. Where's our parse? Okay, so I'm saying let's get rid of program because we only do a line at a time. And when we build, we should see a bunch of stuff because all these places that use program. Okay, so this can't happen. Skip. Well, we can just call parse.step. Oh, no, we don't need the program. It was program, right? Yeah, we don't need program anymore. I guess we don't really need 2 lines anymore. Well. Okay. Program step output. Okay, good. Parse.program program simple print. Again, it's just going to become a one-liner. Okay, we do a step. Yeah, anything with just one line, I think we can just do this too. Okay, so we're going to have to be a little explicit. Parse.line. So just the typing to let it know that we're wanting the line version of this thing, or the parse version. It really is the only dot line, so I'm not sure why it's not able to guess it, but it's not. Whoops. Let's try this one. Tedious editing. But this is what it looks like when you overturn a major decision. Okay. We don't have programs anymore. Oh my goodness. Who knew that would happen? In the old days, the interpreters for these basics, right? They had so little space. They just had to interpret a line at a time. There's no alternative for them. The stuff we have nowadays, you know, it's not an issue. Excuse me. I mean, you were dealing in kilobytes, and you know that's a gigabyte is a million times as much space. So, excuse me. Okay, well, it took a few minutes, but we have eliminated program. Okay, that is good. This is simpler. 16K RAM, yeah. Yeah, I mean that was reality back in those days. I don't know, there's a Radio Shack ad running around, you know, and it's like here, you know, all the fancy stuff you can get, and now it's like it's on your cell phone, you know. There's thousands of stuff. Yeah, 2400 2400 baud. Yeah, you can almost remember the sounds it would make, right? If you ran it much. Well, it had this particular do 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 kind of sound when it connected as it had its conversation. Yeah. All right. Well, I need a drink, and we've been going a while, so let's take a break, just like 3 minutes or so. And but we've made some progress. We got the one step at a line, one step at a time, and we got delete parse.program if we work one line at a time. Okay. I'm not convinced we've got the REPL. I don't know if we've got to make sure there's something to do there, but I think we've made a lot of progress there. So anyway, see you in about 3 minutes. Hey, welcome back. Alrighty. Okay, let's take a look at parse. Okay, this is looking good. A little simpler. And we can see every statement we're going to do is going to come in. The thing that was a little... Let's see, what was that? Oops, get rid of that. It's still a little funny to me, like, is this line thing pulling its weight? And I don't know. I'm not bothered that this is recursive. It's... yeah, that's okay. The thing is, like, our program... let's find program. Program, it has this map from integer to line. The line number is really in the key here. I mean, we could strip off the line number from here. I don't know. Yeah, I don't know. Okay, and then let's look at parser. All right, so where did we put that new line on things? That was Lexer. Let's go look at that. Okay, so program new line. I don't think this is going to show up for us at this point. I get it's kind of a can't happen thing. And it's handy to have this if you are doing a whole program, or it's sort of like Sentinel, you know, at the end when you're searching, if you can stick something at the end, you know, I don't know. Well, let's say you have an array of 10 things and you want to search for them. If you allocate 11 and you put the value you're looking for at the very end, you know you'll get to it. And you just, at the end, you can check whether or not you've exceeded the end of the thing, you know, rather than checking every character to make sure it hasn't blown past. But from the consumer end, you know, you just get a stream of tokens and you get an actual token at the end that tells you this is there. And the reason that's useful is when you're looking ahead in parsing, you always look ahead one. And if you were at the very next to the end and you wanted to have a token to look at afterwards, because you just want to always look at the next token. So we find that convenient. But the way we're doing parsing now, we're only going to look for one statement. We know it has a new line because we put it in there. It probably has one anyway, but regardless, we're putting one in for parsing purposes. And we'll only look as far as the EOL. The fact is there is another token at end, but we don't care probably. It's not strong enough to make me pull it out at this point, I guess. Okay. Yeah, this method's awfully big. Let's just do a little cleanup on it. I'm just going to pull out the contents of the switch statements. Okay, so this should be able to be a method. Let's call it number. And it put above, but I want it below. Okay, and this one is, well, that one's pretty short. Maybe. Oh, that does communicate, doesn't it? Like, here's the job. All of these are easy. Okay, this one is less than. And this is greater than operators. Okay, I gotta admit that's definitely better. Okay, and these. Well, for now it's I'll say keywords and names. I'm kind of anticipating, but that's okay. All right, I'm gonna get all these things down. Okay. There to there. Okay. Okay. All right. So those methods are still big, but at least the switch statement actually just kind of flows a lot better. I see some digit characters, I'm going to turn into a number. I see simple operators, I turn them in. Less than operators, greater than, keywords and names. Otherwise, I don't know what it is. Yeah, that definitely reads better at this level. And you kind of see the entry points for each kind of character. Okay. All right, so I'm happy there. Here's our tokens. I'm going to move this one up just that it's kind of sub rosa. I don't know what to say. Okay, equatable hashable, good. That's pretty good. I think I'm basically okay with this stuff. The only thing that's still giving me pause is these expressions. I just wonder if I could write a generic method. I guess I'd have to give it a set of tokens because some of them take more than one. Most of them don't. Yeah, here's relops. Like if I gave you the set of tokens and the sub thing, could I write a generic binary method thing? I probably could. Yeah, there's another set of tokens. Another one. Some of these are different though. This one has a different structure. This one has sort of embedded in it. Return up 1 minus. Yeah, that's kind of recursive. But this one is not. This one's different. I don't know. The more you go down this path, you eventually end up with a generator, parser generator. These tests I don't need there. I'm trying to keep the tests on the left. And what's program? Okay, that's a good thing. All right, I wanted to do the REPL. We did some minor cleanup. I don't know what we did just now, just tweaky stuff. Okay, let's run it. Okay. I don't know if we set up a run yet, did we? Okay, if I do 10 print 27. Okay, we have this primitive editor. If I say run 27, okay. That's good. That still works. What if I say 20 print, I'm still uppercase, print 20, and I list. Okay, now when I run, we only handle one line. Okay, so let's get that working for real programs. Okay, now we're really doing run multi-line programs. We never really have done it yet because we had no mechanism to get from line to line. Okay, and there's, oh, this is interesting. It's funny. Yeah, I mean, here's program into string. Like, how do I get to the next line, right? I mean, I'm on line 10. Do I really have to walk through all the keys and find the next highest key? I guess I don't have a mechanism yet. Okay. Now, in the old days, right, the program would have just been a big chunk of text and you're on line 27, you would skim forward until you hit the next line in the text, and you'd know from that. So in that case, the Lexer, well, yeah, the Lexer would really be, well, the state of the Lexer is like, what character are you pointing at next, right? And after you parse through the new line, your next pointer would be the next line. So by default, you could just start picking up there and go. We've put more mechanism in. Now I don't know what you can do on dictionary, I guess, is the Swift object for it. Do I have a browser kicking around? Not really. Okay. All right. Well, let's see. Now in our interpreter, right, we want to have a run. We're going to get the program. Okay, we've got the initial line number from the program. When you say run, we call step. And well, now, okay, let me go back to my documentation here. The old basics, they had an end statement, and the original basic, you had to have an end statement at the end of your program, and if it was an error to not have one, and if you didn't have one, I mean, most of these basics, if you don't have one, they provide implicitly. But if you fall off the bottom, then you should stop. And we don't have an explicit end statement here yet. I could imagine the program being responsible to give you one if you ask for it. If you hit the bottom. Okay. But like right here, this thing step, like there should be a while, right? You're going to do stepping while something. If we had an end, that'd be fine. Are we asking while the line number is valid? Yeah, I just don't know. Okay, so I think this is the right place. We're saying run. I really don't want to run forever, so too hard to debug. It's like your next line number. Well, let's say the program knew the minimum and maximum line numbers. That seems like a reasonable thing for it to know. If you ask for something beyond those, I think it should just return maybe it should return an end statement. That would be legit. Let's make the end statement work, and then we'll come back and use that as a terminator and make sure the program range and all that stuff is done. So end statement. Okay. And the syntax is just end. Okay. We've got, I believe we put it in the tokens. End keyword. End. Did I miss it? Dim end. And does not go there. We're trying to be alphabetical here on the keywords. I was trying to do somewhat grouped. I don't know. End is not a reserved word. Okay, so we parse? Well, we don't have an end statement. Okay, so let's add one. Case end. There should be complaints. All right, switch must be exhaustive. Let's add it here. And return output. We're not going to do anything. Or maybe we should, let's, we'll do that for now just to get something in there. Okay, and run tests. They shouldn't care. We just introduced a new thing that nobody calls. Yep. Okay, so parser, we need an end statement. Oh, well, I guess let's add it to parse too. Oh, we did add it to parse. Okay. So the parser, let's find it, parser tests. And I think we'll pretend we did this first. 10 rem. Parser should be result should equal dot end. Okay, and skip. Okay. All right. Parse, well, single line, case, there's line, here's statement. Okay, let's do end. Oops, result equals. Sorry, next token. So we'll consume the end token and result equals parse.end. I'm not sure we're doing. Okay. I guess that's fine. We got methods that do those. This is easy enough. We don't need a method. Okay. And that should pass. Skip is not equal to end. Let's check our token. No, our Lexer. Make sure we gave end to end. Oh, it's missing. Reserved word end goes to end. But we also had a reserved word clear, I think, didn't we? And clear data def dim and clear data. Def and end for GOTO GoSub and for GOTO GoSub if input let next on, if input let next not on, or next not on or. Next not on or. Poke, print, read, rem. Restore, return, stop then. Okay. Okay. End is end. Okay. Skip is not equal to end. Let's take a break in here. Token. Are we getting the right token? That's the first question. So let's run this test. Let's stop here. Parser, parse line. Wait a minute. Parse with line. So I'm confused. Parse line. Okay, let's step here. It has to get there, right? Okay. We'll step in. Try line, step in. If case integer should be okay. Step over. What is token? Ugh. I do that so many times. Print token. Token is error. Exponent value is missing. Ooh. Okay. So, the deal is it looks at it and it sees 10E and it expects a number 10E2, okay, or 10E minus 1 or something like that, that represents a floating point number, but we don't care at this point. That's our first one with an E, so it never happened before. And the reason is we know this is the old, like, BASIC and Fortran and a lot of the languages from the early 60s, they weren't very clean syntactically, and you had these ambiguities, and they would do things like, no, oh, I'm parsing the line numbers, so I should only look for digits, which is probably what we have to do now. And, you know, they would, instead of being, you know, just always consistently correct, or, you know, consistently read this and know what the right thing was, they'd have to say, I'm expecting an integer. Don't go parsing the E's here. And I think we're going to have to do the same thing. Oh, I thought this would be a 10-second job here. Okay. Wow. So the tokenizer. Yeah, this is going to be a little complicated, because the decision about isn't an integer or not is not made at this level. It's you know, where we know we're looking for a line number. It's made down here where we're just taking a kind of a context-free, I saw a digit. Yeah, down here it was like, I saw a digit it must be a number. Okay. And numbers always know if once I find all the digits, I should check if it's a fraction. I'll look for a dot. I'll look for an E. And now the only thing is there, I think 10E3 is a valid constant in BASIC. This thing might tell us. This is the Commodore 64 BASIC. Let's see, does it tell us where numbers are? Okay, numbers, integers, floating point, scientific notation. The mantissa, the exponent. Okay. Some example. There it is, E6. Okay, so, well, the expedient way that I think was common enough is we make our tokenizers smarter. Oh, but this is tricky. Yeah, so we have the program. All right, and we are the caller calls next token, right? Parser up at the very top. Okay, but it knows it wants a number. Sorry, an integer for the line number. Well, next is coming in because of our sequence. We're a sequence, so you can call loops and stuff on them, but really it's like the first. It's kind of like after a new line, the first token parsed should be an integer. Okay, and implicitly we were at a new line in our initial state. So so I think what I hate to do this because it's just really awkward and arbitrary, but I think what we got to do is we got to say the Lexer, when you first call it, we expect you to be looking for a number. Okay, and if I'm an integer, okay, so we should have some state that says I'm looking for an integer, not an arbitrary number. And then once you've found the integer, you say, okay, now I'm looking for arbitrary numbers. And when you hit a new line, you say, okay, I'm looking for integers again. Okay, so that's quite a change. Okay, but it's the reality for BASIC. Now the other way I could do it is I could imagine a next method that says, like, do you require an integer at this point? Okay, and if so, then same kind of thing. The flag would tell it. I think it's safe to. In a way, I think it's better for the Lexer to manage that state and just know, like, the lexical analysis is the first thing in a line is always an integer, and you should only look for integers at that point and manage when it's safe to look for floats and stuff. Okay, so let's do some Lexer tests. We did some line number stuff. Let's see. Line number internal spaces. Okay. Remark, line number leading spaces. Yeah, I think at the beginning of line numbers. Okay, so let's say func test first token always expects integer. Okay, and so if you check token, one E, one end, okay, you expect an integer 1. Okay, and I think this is going to fail. No, I don't. No, I do. Because of the E. Yeah, I think it's going to see one E, and it's going to say, there's an error, exponent value is missing, right, like we saw in the other thing. Okay. And okay, it's optional because this is optional because it's a sequence, and it could be a nil at the end, but that's okay. This is wrong. All right, so let's add that flag. Okay. This flag is, let's see, what do we want to call it? It's something, it's like expect require integer, or expect integer. Looking for line number. Yes. And it starts true. Okay. And now we need to use that. Okay, so here, if looking for line number, then do this, else do that. Okay, and for now, I'll just say return number. It'll still fail, but I'm getting structure in there. Okay, same failure presumably. Yep. Okay. Now number is float equals false value. Well, is float. Oh. Right. We either get an integer or a float back from number. So maybe we just have to require that it's an integer. Okay. If it's looking for line number, we care, and we have to make sure that it is an integer. And I don't know, how are we handling errors? Oh, we return an error token. Okay. Nope, that's not the right way, is it? Sorry. Because it's going to have parsed that E already and given up and given error token. So no, we have to do the other way. Okay. If looking for line number, we're going to return integer, which is going to look a lot like number. Okay. Okay. And we don't care about this. We'll take value equals repeat. So that gets all our 0 through 9s. We don't have to worry about that. We don't have to worry about that. We don't have to worry about that. We're just doing this. I think this is going to simplify some things too, though, so maybe it's not as bad as I'm fearing. Unexpected non-void. Yes, I did. Token. Okay, so we would run through this. Value, these ifs would not be correct, and we would return that. Okay, I think that's better. Let me reflect what we're really doing here, which is force line number to be parsed as an integer. One end was interpreted as 1e, which is invalid float. Is an invalid float. Okay. I guess that's more of a comment. Okay. And that failed. Oh, passed. So this should pass now, right? No. Oh, we just have a breakpoint. A bunch of breakpoints. Oh. I wish there was a delete all breakpoints right there, but I'll do it this way. Still failed. Okay. Let's see. Back to our our Lexer tests. Okay, so this one parses as an integer. Now, ooh, why did that one not like that then? Maybe I should run this with, let's see, parser. Okay, let's do stop there, because the Lexer test passed. Okay, this test has still got a problem. Okay, so print. Oops, darn it. Print token integer 10. Okay, that seems good. Step in. Step in. Line 10. Over. Should see our end token. Good. Where'd you go? End of line. Require end of line. Yes, that should be fine. Next token. Return parse line number. Statement parse. Oh, what is the problem? Not equal to end. Did I just not do it normally? Okay. And parse line. Line number statement parse. Oh, I did a return here somewhere, right? Result equals parse.end. Return that. I'm a little lost here. Okay, let me break down here. And again. Okay. Okay, statement parses an end. We're going to look for an end of line. Okay. I would think this would be what's returned. Line number. Whoops. P statement. Parse. Line number with a statement parse of end. Okay, let's go out. I wish I could capture these and see them as they go. But that's what line returned. Let's go out and out. Okay. And I don't think result exists yet. Oh, no. This assertion's just wrong. It should be dot line of 10 dot end. Okay, let's see how that goes. Kind of the point. And take these out. Continue. Okay. Oh. All right. All right, that was the simplest thing there. But I don't need to reset that? I do. Okay, so func test numbers passed line number expect float. And this is a change, so I think it's good. We have something that checks multiple tokens. I don't think we do. Yeah, we do it like that. Ugh. Okay, well, that's what we're going to do. We're going to do this kind of thing. Okay, so 10 print 20. I guess I can, yeah, we don't need the new lines because we put them in. All right, so token equals Lexer next. I should see a 10. I should see a print. And I should see a float. Okay, and this should be, oops, lowercase. Print, and this should be dot float of 20. Is that right? What do we call those? dot number number. Number 20. No, this is Lexer. Is that right? Lexer is doing tokens. Tokens produce numbers with floats. Okay. Now, I think it's going to return an integer here. And we can clean that up. Yep. Integer. Okay. This is the part I said was actually going to be a little better. Anything after the line number should be interpreted as an integer. Okay, so looking for line number, where'd that go? We start off looking for a line number. In here, this should now become false. It's false. And this is number. Okay, this will still fail. And we may have some other tests to adjust from this. Right, so the reason it fails is down in the bottom of number. So down here, we decide whether or not to return a float or not. We don't need that now. We're just always going to return a float. Oops. We're always going to return a float with our numbers, so we don't need this variable either. Okay. So yeah, so after the first one, after the line number, even is this true? I'm thinking about GOTO. We can always get back to the integer in the GOTO. We're going to have to do some work there. But before, it was always, no. Yeah, we're going to have to do some work there. Let's make sure the Lexer test is passing first. Okay, so this one should pass. Oops. Is float. Okay, now everything, there should be some failures. At least our GOTO should be complaining. Yeah, 2 remarks. Ooh, that test is not legit. Our Lexer only works a line at a time now, so we don't have, this test doesn't apply. Okay. Print a number. Integer 25 print 42. Yes, this should be a float now. Is that float or number? Number. Okay. Exponent is missing. Check token. Yeah, that's not really correct. We're going to have to do more like this other test. Because basically it's assuming, now we're assuming we're passing in a line, and this is not a line. Okay, so we will do 10 print this. Oops. Okay, so this token equals 10, this one equals print, and this one should be an error. it should be this. Error exponent value is missing. Okay. So print 14.3 should see 10 print error because that's a weird number. Yay. Okay. What else? Parse GOTO. Okay. Right. Skip. Okay. I wasn't expecting that. I think right now we do skip is really an error situation. Okay, so let's go to the parser for GOTO. GOTO. Right. It's not an integer, in fact. It's going to be a float, a number. Okay. So we'll pull out the number, convert it into an int, which is what GOTO wants. But yeah, because it's not the first thing in the line, it's not an integer. It's a number. All right. Let's run them all. Four failures. Okay. Test two remarks. No, that's not there anymore. Number lexing. Yeah, same problem. You want, yeah, it's just, okay, let's make a helper. Okay. Check token. Well, it's really, let's say check number. Okay. And it's going to take a string number. Number as string. Well, maybe I can just say string. And an expected of type token. Okay. And the body is going to be like this. Well, this far. We're going to embed it in a print statement. The string. Maybe this is just input. Okay, so we'll embed the input in here. We'll read the line number. We'll read the print. And then this token should be expected. Okay, and these can call check number. And this should be number now. Okay. All right, and let's run them all. Let's run them all. All right. So what we've done is the first number in a line is always an integer. The line number. Remaining numbers in the line are always float. And that's okay, that's a good thing. Now, I think our integer, we can do a slight improvement in our tokens. We've got integer. I think at this point, integer could just have int, and there'll be some complaints, but our int, we know it really is an integer now. This is factor. Case integer. This can't happen. Okay. So, yeah, we'll never put an integer in an expression because it's never, the line number is never part of the expression. So this no longer is even an issue. There may be some other consequences. And can I convert values of float to integer? Okay, here's our integer. This should just be an integer. Sorry, it should be int value. Int value. Okay. We'll run that again. Somebody else should complain. Okay. Our expression. Okay. Whoa, what's the matter? Expected number or left parenthesis. Oh, once again. Expression. Oh, we're paying for this. Oh, okay. So what happened is we pulled out that thing, that helper method, to only do expressions, and now the expression gets parsed as a line, and it sees that too, and it says, oh, that's the first thing in the line, it must be an int. And we don't handle ints in our expressions anymore, so all our expression ones broke except one error case. And that's me taking that shortcut. Maybe we can't test our expressions that way. Yeah. Well, it's really the same problem. Oh boy. The one we just did for the Lexer, we could pull out a helper that puts 10 print in front of this, and then assert on that. Let's try that. Func check expression throws, and you're going to give it an expression of type string and an expected parse. Okay, let's hit some returns here. Expected of string and a parse. Okay, and we're going to do all this stuff. Okay, we got an expression. This is parser.parse input. Let's let input equal 10 print expression. Okay. Parser equals parser, parse on input. Okay. And now the result, this is, well, it's I think this will get us where we were. Okay, so throwing functions occur. Okay. This is, I believe, the equivalent of what we have. If I called check expression, passing in this, and oops, this parse tree. Okay. Type parse has no member op2. Okay. This is an expression then. Okay, and our expected, we're actually going to be looking for dot line 10 dot print expected. Am I missing one? Print line. Okay. Expression line equals. Yep. Okay. Call can't throw, but is not marked with try. I don't know what you're talking about. Call can throw. Oh, this doesn't really throw. Okay. And then this goes away. All right. That should fail the same way. Thank you so much. Oh, no, it shouldn't fail the same way because I put the line 10 in. Okay. That passed then. That's good. Okay. Same thing then here. This is check expression. Check expression. We're going to pass in this. And the expression make. Okay. Well, I got to admit that's not ugly. Check expression. Expression dot make. Is this the same? I think it is. Check expression. Well, half of these should pass. Let's make sure we're making progress. Okay, yeah, we're making progress. All right. Check expression. It's a better test, frankly. There was duplication in these anyway. And I don't think I'm coming out that much better however I do this editing. It's actually a better test on several fronts, because that expression method we added that had to know the internals, we can get rid of that now. We're not calling it. Oops. Now this one, oh, he's still calling exception. Error one factor. Well, we'll come back to that one. I don't know what helpful thing it thinks it's doing there, but okay. All right, so the regular test should pass. The error ones we didn't deal with. 2 or 3, yeah. Okay. Minus, oh, this is interesting. Why did that fail? Skip. Line 10, token minus all that stuff. Okay, interesting. This one. Now, we're not throwing an exception. I guess. All right, let's say check. Oh dear. All right, I think we just need the top half of that check expression method. I don't think we need the do catch. Okay, 10 print. Expression equals that 10 print. Parse the thing. All right, the deal is our error message should be in the error messages. I'm going to say empty. That should be wrong. It should be this. Is that what our messages contain? I think they have parse errors in them. Error messages contains parse errors. Yeah, so that should be what's in there. Okay. And that makes me want to add an assertion up here. Where's check expression? I should get what I want, but I should also have this being empty. Okay, so I'm adding to my test something that probably should have been there. And I think this unary minus thing might Might show something there. 4 failures. Okay, so I'm making more trouble for myself, but extra characters at end of line. Ooh. Extra characters at end of line. Interesting. Okay. Unary minus. Is that also extra characters at end of line? Okay, there's something with our unary minus. Okay, interesting. Interesting always means bad, doesn't it? Line number to be parsed as an integer. Excuse me. Okay. Before I forget, this kind of compromise approach is no longer being used. Same 2 errors should, or same 2 failures. Are you testing? Tester. Oh, I didn't change that one. Okay. The error should be expected number or left parenthesis. Which sounds right. Oh. Okay. Okay, 4 failures, all on the unary minus side. Okay, so let's re-examine our unary minus. Down in expression land. Okay, and it's right around power. Okay, so we're seeing characters at end of line. That makes me think we forgot to chew up something. Okay, if minus equals token, do next token, then try power, and let's see, our example test. Okay, -2, arrow 3. Okay, so we see minus. Let's try power. Well, power says if it's not minus, then try factor, which is 2. While you get an exponent, read them. Capture the exponent, skip over it, read the factor. That should be the 3. And then return the value. So I would have thought we consumed all that. Okay, now let's try the minus minus. Minus token, skip the minus, call power, comes in, it sees minus, skips the minus, calls power. Interesting. And where's that at end thing coming from? Is that the, what was the name of the extra characters at EOL? Okay, so this is line. Let's break here. I think this one's simpler. Okay, let's print token minus. Try statement. We skip past the line number. Did I not pass the right things into the test? Oh, no, check expression. That one seems okay. Tempered expression. Okay, we're going to break it. 42 again. All right, where's that test? All right, let's run this again with the break there. Okay, parse. Lexer input, next token. Cancel. Step over. Should be unknown, I think. Yep. Okay, step over. Should be integer. I guess I could just leave this here. Whoops. Here, token is integer. Okay. Step in. Try line. Okay, we'll continue. Down here. Whoa. I thought that we had a break there. Okay. We got in here, so it was an integer. We consumed it. We called parse. And now token is minus. It's like we didn't consume the statement. I guess the statement must have failed. Well, let's break on print statement. I'm going to assume we got in here. Okay. Parser test. Run this. I don't know why it always wants to put it in the wrong side. Okay, print statement. Let's see, token is print. Okay, so we'll step over. And token should be, oh. Okay, that's the problem. Integers don't happen there. That's only floats or numbers. Oh, there's number. Okay, token is minus is a valid start. Okay, so we left out one. Because print, well, we're going to come back to this thing. Ugh. It's almost like this should be the default. Okay, so integer can't happen here. Minus can. And left paren can. Let's go to our grammar. Is there anything else that can start an expression? Okay, and they call this first. If you ever get into grammars, right, you'll analyze it and you'll find the first set, which is the possible tokens at the beginning of of a left-hand side. So this thing that's calling or, calling and, calling negation, now we can see not can get in there. Okay, sub-express return, power, minus can get in there. Integer cannot, we took that out, number, float. So it's either got to be not, minus, number, or float. Not, minus, number, or left parent. Okay. And our message, where's that message? Expected number, left parent. I think I'm going to rename this to expected start of expression. Okay, it could be better, but I think that's good. All right, let's run all our tests. Stop and run. Get rid of all our breakpoints. Can I do that up here? Deactivate breakpoints. Okay, and continue. Right. Okay. So we make minus a valid leading character for an expression. Okay. And where we are on this, line number to be parsed as an integer, I believe we're done. Okay. And that'll give us a place to pick up next time, is to go ahead and get this end statement working and run multi-line programs. So thanks for joining me today. Next time should be Monday at 9 a.m. to 11:30 Central Time, 10 to 12:30 Eastern Time, or 3 to 5:30 UTC. Again, have a good weekend, and I hope to catch you in the future. Bye-bye.